For the record, I would also note that is probably not the strangest thing that's come in by any means.
This is Technologically Speaking, the official podcast for the Department of Homeland Security Science and Technology Directorate, or S&T as we call it. Join us as we meet the science and technology experts on the front lines keeping America safe.
Hello and welcome to this episode of Technologically Speaking. I'm your host, John Verrico, and with me today is the director of the National Biodefense Analysis and Countermeasures Center, Dr. Nick Bergman. Dr. Bergman, great to have you on the show. How you doing?
I'm just fine. Thanks for having me.
Hey, so you are new in this position as we call it the NBACC because we like acronyms here. You know, National Biodefense Analysis and Countermeasures Center is quite a mouthful. So for the purposes of our discussion, can we just call it NBACC?
Yes, we do that every day. Yep.
Okay, good. Great. So I know you are relatively new in the director's slot. I think you're just coming up, as of this recording, you're coming up on about a year, but I know you've also been around for a number of years there.
Right. Yeah, I've been here 14 years, but only 1 year in the director's spot.
So how do you feel about your new gig?
I'm enjoying it a lot. I think NBACC is really in a great spot. We're kind of poised to grow in a couple of big ways. And I think biodefense is, you know, as much as it's getting more difficult every year, I think it's getting more interesting. And so for those of us who are in the field and enjoy solving puzzles and attacking really important problems, this is a really good place to be.
You know, for the sake of our listeners who have no clue, perhaps, of what the NBACC is, how would you describe it to your great Aunt Tessie sitting at home?
Well, it really takes a little bit of history to understand the context of NBACC. NBACC was really started based on some observations the country made collectively following the anthrax letters of about 20 years ago. We kind of collectively observed that we didn't have a place to do the forensics for that. We had forensics labs and we had containment labs, but we didn't have both in the same place. And so we were really stuck. And so part of NBACC's original mission was to serve as the place in which those kinds of analyses get done. The other thing that we observed as a country was that a lot of the decisions that have been made up till that point about what things that we as a country would worry about were based on data that weren't necessarily collected using the agent that we really cared about. So for instance, we would base our assumptions or our strategy for dealing with the bacillus anthracis threat based on studies that have been done with neighboring species that weren't nearly as dangerous. You know, if we have an event, we have spores spread all over our office building, say, how do we clean that up? You can do studies like that with a real office building and Bacillus subtilis, which is kind of a close cousin, or even a closer cousin like Bacillus thuringiensis, which is used as an insecticide. But you can't do that with Bacillus anthracis. So NBACC was really born out of those two needs, you know, the need for a forensics place that could handle high containment items and a place where we could do the applied research that frankly, we can't do anywhere else. And so that's the basis for the two science programs that are running kind of side by side within NBACC.
Let's talk about those different programs there.
Sure.
So there's the National Biological Threat Characterization Center. Right. And then also where you had spent a majority of time at the National Bioforensic Analysis Center.
Right. And, you know, following on your lead, we don't tend to call them that. We tend to call them NBACC for the Forensic Analysis Center and Threat because NBTCC doesn't have any vowels and it's difficult to pronounce. But we tend to shorten them. And so the Threat Center is really about that second mission that I mentioned. It's about finding ways to fill the knowledge gaps in our biodefense knowledge, the basis for understanding biothreats and making decisions about how to prepare for them. Finding those knowledge gaps, filling those, and then in doing so, making better decisions in the country about what kind of drugs do we stockpile? What things do we need to worry about in terms of vaccine development? So that's the organization we refer to as Threat. NBTCC. And BFAC is the Bioforensic Analysis Center. And that is, as you said, the one I was the director of before coming to this job. They are the place that FBI would take any sort of evidentiary material from any sort of crime that really needs biocontainment. So anything that might be biologically dangerous from any sort of crime would come here for that kind of analysis. For sure, any bioterror or biocrime stuff would come here.
That's a huge mission right there.
Yeah. It's a very interesting place to work. they have become what amounts to FBI's Special Projects Lab, in the sense that anytime FBI has evidentiary material that doesn't fall cleanly into some of the categories that Quantico is used to dealing with, they'll often bring that here because we can give it more special treatment and more advanced analyses. And so I say it's an interesting place to work, because when you're in that position, you never really know what FBI is going to bring you, but you can be assured they will bring you something different every week, and you'll get a different puzzle to work on pretty regularly every 2 days.
All right. So I have to ask this one: when you're talking about, something different every week and it's something completely unique and interesting. I remember there was some mummy identification that NBACC was involved with a while back.
Yes. We had I think we got the tooth of a 4,000-year-old mummy. It was the Boston Museum of Fine Arts had some materials collected from an Egyptian gravesite. And what had happened was, when they were collected, those materials from the gravesite, the person opening the grave had observed that at some point in the past, grave robbers had gotten in and they had kind of more or less trashed the place. And so ostensibly the grave was supposed to contain the sarcophagus of a governor, a royal governor, I think, and his wife. But what they found when they got in was that both coffins had been smashed and there was only a head left. And the head was sitting there, and it wasn't clear whose head it was, the governor's head, or the wife's head. And so the question became for the museum, and I think they had it on display, the head, for quite a while, with a caption or a little, label that read, "We're not sure whose head this is." So I think, if I remember right, they had approached Harvard, because it was right down the street, and asked, "Could you help us sort out whose head this is?" We all kind of put our data together and came up with a pretty firm answer that it was the governor's head, because we got a clear signal that it was a male tooth that had been extracted. So it was a very fun project. But for the record, I would also note that is probably not the strangest thing that's come in by any means.
So Nick, then what was the most interesting thing?
We get a lot of interesting things, and we have this running joke that every time we think we've seen the most interesting thing or the strangest thing, FBI brings us the next week something worse. But unfortunately, I really can't talk about a lot of the interesting things we get. It's just the fact of being associated with FBI casework and not being free to share details about cases that are active or that haven't been fully resolved.
Well, I can certainly understand that. We understand law enforcement sensitivity around here in the department. So certainly, incredibly interesting stuff. But I have to ask, how did you get involved in this? What made you go into this kind of a career field?
Right. I was pursuing the normal science rat race, which is to say I'm teaching classes, mentoring grad students, building a lab, getting grants, all that. And it was going pretty well, but there were some areas that I was really intrigued by. And I started looking around trying to see how to get into those. 'Cause, in an academic science setting, you really can't get into it without funding. And so, I went up and met with the folks here, and they hired me as the director, or the founding manager, I guess, of the genomics group. And manager is a bit of a misnomer there, because at that point it was me and another guy. So it was two. That group became about 30 people, and we were doing some really cool stuff, and it became the basis of a lot of what NBACC does now. And I've, been here ever since. It's just been something that I found I really enjoyed. You can see the impact of your work almost immediately a lot of the time. So that's not something you get in academia very often.
That makes so much sense. I hear that a lot from especially the scientists that work here at S&T, the fact that it's not just basic research. It's not just science for science sake, but it's actually, it's applied science, and you can see the results and know the impacts that you're making on the world.
Yeah. When I was in the academic world, we used to talk about how one of the things that we're always working on is our 2-minute pitch. The 2-minute spiel that you could give to a program officer talking about why the work that your group is doing is important. And to be honest, it was always difficult within 2 minutes to convey some level of importance, some level of impact, because you were doing basic research. And that's not always easy for someone who isn't in the field to see utility in. I guess in some sense, that was what drew me to this place pretty quickly. The fact that the 2-minute pitch is easy.
So what is that 2-minute cocktail party pitch?
Well, it's saying that, biodefense is something that is is critical for our national security. It's critical for our public health security, our nation's infrastructure, and just the position we have in the world. We've all seen that going through COVID-19, that something that doesn't even seem like a threat can come out of nowhere and change the world. And biodefense is about trying to mitigate the risk of all of that, whether it comes from nature, it comes from somebody doing something they shouldn't, or somebody deliberately trying to attack us. Biodefense is about getting ready for the threats biology poses. And frankly, we need a lot more of it. So it becomes very easy to defend what you're doing and how you're doing it when you can point to concrete examples like COVID.
Right. Well, you opened the door to COVID. So let's talk a little bit about some of the COVID work that was done at the NBACC.
So one of those capabilities for the Threat Center is that we have a really strong aerobiology group, a group that's devoted to basically understanding the behavior of aerosols and specifically infectious aerosols, in fact, aerosols that contain viruses or bacteria. And so especially as it became more and more clear that this virus was not spreading by surface transfer, it became more and more clear that was the niche that the Threat Center really could kind of dive into and start contributing. And so that's where they started thinking about looking at how this virus in an aerosol does in the environment. And that fed into a lot of information that we could share with the White House, the task force, and with the general public in terms of helping them understand that outside is better than inside, sunny is better than dark, humid is better than dry. Because those are all conditions that we identified as conditions that were less favorable to the virus's survival. And so it was those kinds of things that we started launching on right away. And within a few months could publish papers and get those data out to the public where we could start getting guidance out to everybody saying, hey, move your birthday parties outside, that kind of thing, which it's very difficult to quantify the effects of that. But I think everybody would understand that it probably saved too many lives to count.
And that's the unique thing about this kind of work too, is, how do you quantify the effectiveness of the work that you've done, right?
Yeah. This is just generally true. I think, I've always thought about it the same way I think about my kids' bedtime when I had little kids. You didn't necessarily know when the best bedtime was, but you knew when you had passed it. And so it was only something that was knowable if you missed it. And it's the same thing with a biodefense program like this, where you can't necessarily quantify or provide data to show how well you're doing, but you can definitely see when a program was ineffective. And, thankfully, I think we're seeing that these programs are working really well. We've done lots of stuff in both programs to really strengthen the nation.
Yeah, I tell you, I remember, all of that we went through throughout that period, getting information out. And basically, it came down to, practical advice, which, a lot of the stuff that we do in S&T doesn't really translate to something that the average citizen can do to take action for. But in this case, it did. People were told, hey, when you go to the supermarket and you go grab that shopping cart, instead of getting the one that's inside in the air-conditioned building, take the one that's been sitting in the outside, corral, which has been sitting out in the sun.
Right. Yeah.
Nick, this is just one set of examples for the significant impact that the NBACC and the brilliant minds that work there were able to do, and the impact that they made. What are some real highlights of your time there that you can talk about?
Well, COVID is obviously a biggie. We've done similar things for lots of other pathogens that I can't list specifically. And so we've got a lot of data, and those data all have gone into, things like sharing with HHS and the Assistant Secretary for Preparedness and Response in order to kind of shape the strategic national stockpile. A lot of our data ends up going into their hands where they're making purchases. And these are huge decisions for the country. Now, do we have 600 million doses of this vaccine, or do we need 10? Or which drugs should we stockpile based on the threat that a particular set of bacterial pathogens poses? Those are all things that end up being billion-dollar decisions. On the NBACC side, I can say that they have been asked by, quite a few different countries through the FBI. A number of countries have reached out and asked for NBACC's help in analyzing samples. We contributed to some pretty significant investigations, notably some anthrax-laced heroin that was circulating in Europe about 10 years ago. And BFEC was instrumental in sorting out where that heroin got contaminated and whether it was a nefarious event or accidental. So that was, working with Interpol and a few other agencies within Europe. And BFEC has done things with NASA. I think both programs have really had a huge impact, even if you might need a security clearance to really understand it.
I have to laugh when you say stuff like that but it is so unfortunately true that we can't talk about so much of these successes, but the whole work is really interesting. And one thing I want to make sure that people truly understand, the things that go on in this, highly secure government biological laboratory that is on a military installation, is that we are not in the biowarfare world at all, but we are in, like you said, the characterization and forensics. We're looking at understanding these biological threats, understanding how they transmit from host to host, how they impact the communities, the impacts, and more importantly, how to clean that stuff up, because the decontamination side is just absolutely huge. And people don't really realize that. So I'm hoping that our listeners get a good understanding for the kinds of work that we're doing. And so, you have special laboratory capabilities there. Can you describe a little bit about some of the unique features of the lab that we can talk about?
Yeah, sure. And I should note too that, one of the worries that came out from the start when NBACC was being proposed was that there would be a perception that we were doing something on the offensive side, which has never been true. But just to mitigate that risk, we do have this process where every project that happens in the building is run through a number of steps where people first here and then at DHS are looking at it to make sure that there's no possibility anybody could perceive this to be an offensive project. So we just wanted to add that.
No, that is a brilliant and very important point.
Yeah, it's just, we want to make sure that everybody understands that we are entirely defensive in nature. So with that said, thinking about our labs, we have a pretty unique lab environment. We tend to talk in BSL-3, BSL-4, biosafety levels. Most academic labs are BSL-1 or maybe BSL-2. I tend to think of BSL-1 as something akin to a high school classroom where, for the most part, if you don't do anything stupid, you'll be fine. There's really very little that'll really hurt you. And BSL-2 is slightly above that, maybe more like a doctor's office, where there might be some things that could make you sick, but it's nothing that will kill you and nothing that you can't mitigate pretty easily with gloves and, antibiotics or something. But most of the work we do is at BSL-3 or BSL-4. Those are the top two levels. BSL-3 is something that would look, I think to people on the outside, it would look a lot like an operating room. In BSL-3, our lab staff are wearing dedicated scrubs. They're wearing shoes that are dedicated to that lab environment. They don't ever come out. So all of our clothes are changed going in. We're also wearing lab coats. We're wearing gloves and sometimes artificial sleeves, Tyvek sleeves. We're also wearing what we call PAPRs, a powered air respirator. And so this is a respirator that fits over our head with a hood, and it ensures that all the air that we're breathing actually comes through a respirator, a small respirator that we wear on our belt.
Oh, wow. So that's in the BSL-3 level.
Right. So that basically ensures that even if we have a mishap in the lab where somebody drops a tube and it spatters or something, we can ensure then that none of the air this person was breathing was ever contaminated, because basically the design of the hood is such that the air is coming in through this powered unit that rests on your belt. It goes through a HEPA filter and then gets pushed through a hose to basically an outlet on top of your head. And so you constantly are having your entire face washed by this stream of purified air. And so even if it's not entirely airtight, it doesn't have to be, because the airstream is constantly flowing down over your face. And so anything in the room is not going to get to you. So that's BSL-3. And then when we go to BSL-4, now you're talking about wearing what?
The moon suit.
Basically what people on the outside would think of as a spacesuit. I guess the one thing I would note there is that, so now you're getting a full body enclosure by this suit, and you're moving from air hose to air hose as you move through the room. You're always connected to an air hose. When you disconnect, you have about 5 minutes to get to another one. Now, the key point there is that those suits don't need to be airtight. And so this is kind of a common misconception that, the suit needs to be airtight. If you ever have a little leak, that you're in trouble. And that's not generally the case. What you need is positive pressure. So if you can imagine having a small hole in the middle of your suit, if I pump that up with air, what happens is the air is constantly pushing out that hole. And so as long as there's air pressure, positive pressure inside the suit, nothing from the environment, no virus that's floating around in the air in the room can ever get into that suit because it's fighting the airstream coming out of the suit.
Right. It's continuously being pushed out.
Yes, basically.
Right.
Yep.
Yeah.
And so it is a little funny to watch these people working because they look a little bit like marshmallow people.
Right. And it's interesting that the suits themselves are positive air pressure, yet the rooms are negative air pressure.
Right. So it's a little tricky. And this is one of the unique aspects of our building. The biocontainment envelope, this is kind of this term that we use a lot, is based on air pressure. Our labs, the BSL-3s, for instance, are not airtight either, but we can maintain the bacteria, the viruses in those BSL-3s without worrying about them escaping if we can maintain a negative air pressure in those rooms such that if you look at the air coming in or going out, it's always coming in. It's always coming in from the hallway. And so there's no way those viruses can ever float on the air current out of the room. And so we're constantly managing, and this is one of the tricky bits of our building. We have an automation system that basically, I think it assesses pressure at 40,000 points every few seconds and basically constantly adjusts to maintain these pressure differentials. And that's how we maintain the safe environment within the labs.
Did you say 40,000 points?
Yeah, it's a pretty involved system.
Well, ever since the lab first opened, and I've been here long enough to see it constructed and all of that. And so I've always been fascinated by the capabilities there and the brilliant people that are working there. So let's talk about some of the other really kind of cool and interesting things that you are capable of doing there, and some of the great people that you're working with.
The thing that springs to mind immediately when you talk about our building and the people is the fact that nearly every other biocontainment lab out there has an annual shutdown cycle. And by that, I mean, they might decide we're going to take the month of August off from science and we're going to do maintenance. So this would be when they would basically decontaminate the labs and they would open them up. And now we can bring in equipment. We could do maintenance stuff. And so you take a few weeks where the labs are, in our lexicon, they're cold. This lab, because it's connected to the FBI forensics mission, cannot ever go down. And so we have a record now of, I think we've been hot since, I want to say the date is December of 2012. And so we've been hot for something like 4,000 days straight, which is just unheard of in the biocontainment world. And so,
but you got to be ready. You never know, right? You never know
exactly,
when there's
right,
going to be something, an outbreak or some sort of forensic evidence.
Right, exactly. I can't ever tell the FBI, we're going to close down for a couple of weeks and we'll see you later. It's just not going to work. So I think the single biggest accomplishment in terms of our building systems, our people, is maintaining the building on an up and running status for 10 years plus without a break. We've never had a day where we were offline. And that's, entirely to the credit of our infrastructure folks are just awesome. We have all the trades in-house. We have, IT folks, we have carpenters, we have electricians, plumbers, and these guys are all not only really good at their job, but they're actually able to go into the biocontainment labs and work at BSL-3 and BSL-4, which is just unheard of. Having a plumber who's BSL-4 qualified is just, they're very difficult to find. But This is how we can do the work. We never shut down.
It's a lot for your safety record as well.
Yes, right. We have a really good safety team who is constantly trying to make sure that whatever we do, we can do it as safely as possible.
When you're working with pathogens like this, you get this kind of an insider look at what's going on in the world. What keeps you up at night?
That's a good question. If I'm really honest, the stuff that keeps me up at night, I can't really talk about. There certainly are things that make me worried. One of the challenges in working in a place like this is you realize early on that you're never going to be fully caught up. The best we can do is try to defend as best we can. Now, with that said, from a scientist's perspective, this is a really fun place to work because it presents people here with new problems, really interesting scientific problems every day. There's just so many things here that I feel like I could do, for the rest of my career and be very happy.
Well, it sounds like it. And, I get that feeling from you. We do have a chat, and with all the folks there too, people are really excited about the work that they do and extremely passionate about it. And, with your, and I don't want to use the word exposure because that has different context in a laboratory, but with your familiarity, I guess, with biological agents and such like that, when you go out and about in the real world and you see people, maybe wearing masks, not wearing them properly, how do you feel about stuff like that?
I understand that not everybody wants to wear a mask. I don't want to wear a mask all the time, but I think when I really stop to think about it, wearing a mask is better than being sick for a week. So it's something that I generally have come to think of as an acceptable sacrifice. If I think there's a fair chance that I would catch something, even just a cold, I'll often put a mask on. I do keep sanitizer in my car. I've become a little bit of a germaphobe.
I could see how that would happen. I mean,
yeah.
I know it bothers me when I see people coughing and not covering their face, or it drives me nuts when you see people wearing a mask, but it's down on their chin, or, they have it,
Yes.
their nose is exposed with their mouth is covered.
Yes. I will say that people wearing masks halfway has driven me crazy for a while, just because I feel like it's no less uncomfortable wearing it properly. And frankly, I just don't see the point of having it on where you're doing nobody any good. I don't understand that, but I also am not, I'm not going to pick a fight over it. I'm just going to let people do what they do.
So this might be a little personal, but do you get your flu shot every year?
Yep. Flu shot and the COVID booster. I've already had those. So I'm a big believer in science, as you might imagine. And I think the science just says, even in a bad year, the flu vaccine is worth getting. So, and bad year, I mean, even in a year when the strains of the vaccine don't fully reflect the strains that are in circulation.
That's something that a lot of people don't understand too about vaccines and the different strains of illness. How would you describe that to somebody who's like, well, I got the flu shot and I got the flu anyway, because the flu vaccine isn't work.
Yeah. I mean, there's a committee that gets together and tries to figure out which strains do we think are going to be circulating in the next flu season. And they make their best guess, and they're basing that on a lot of data, but they don't have complete data. And so occasionally they find that there's a strain circulating by the time flu season that comes around that is not really represented in their vaccine picks. And so that vaccine is not going to be fully protective. It's basically them doing the best they can. So it's a tough situation they're in. And believe me, I fully understand that science is messy. And there are a lot of things in science that are based on less than perfect data. And you have to kind of draw the conclusions you can and understand that there's some uncertainty there. And that's just how science works.
Dr. Nick Bergman, thank you so much for joining us today and explaining some of the amazing work that goes on at the NBACC. All of that has been, just an amazing conversation. But there's more to Nick Bergman than Dr. Nick Bergman or, Director Nick Bergman. Tell us a little bit about Nick as a person. What do you do when you have your downtime?
I've got a pretty typical life. I have kids, and my wife and I live in this really nice community. We're about an hour outside DC. It's not hard to get to the big cities, but at the same time, it's very small town America. Frederick is awesome, which is where NBACC is. And the NBACC community itself, the people here, we have a great group of people. A lot of us have really been drawn by the mission, but we stay in large part because of the people here. It's a pretty normal life, but we like it a lot.
Says the man who is out there saving the world. It's a pretty normal life. That's what I love about you, Nick, and about, some of the other folks at NBACC. They're all these really super genius PhD holding, deep thinking scientists that are doing supremely important work, are extremely passionate about it. Yet it's that humility that I think is probably one of your greatest features.
Well, for the record, I think this place helps you with that. Every time you think you've got it all figured out, I can guarantee you that somewhere from someone, whether it's FBI or from nature or from one of the other partners, you will get a problem that brings you to your knees intellectually. So it's a very easy place to stay humble.
And at the same time, you leap at the opportunity to tackle those challenges.
Absolutely.
This has been a conversation with Dr. Nick Bergman, the director of the National Biodefense Analysis and Countermeasures Center, otherly known as NBACC, because we in government love our acronyms. Thank you so much, Nick, for joining us today.
My pleasure. Thanks for having me.
Thank you for listening to Technologically Speaking. To learn more about what you've heard in this episode, check out the show notes on our website and follow us on Apple and Google Podcasts and on social media at DHS SciTech. DHS SCITECH. Bye.